Approximating areas with Riemann sums. So let's say we want to find the area underneath this curve from 2 to 6. This isn't like in 6.1 where it was just simple, the whole graph was just straight rectangles, triangles, or circles. This is just a curve and there's nothing we can do what we know so far in order to approximate the area. So one thing we do in calculus as we're introducing integrals is we can approximate the area underneath this curve by drawing rectangles underneath. So from interval 2 to 6, right, I'm just using 4 sub-intervals here. If we draw more and more rectangles underneath, make them skinnier, and we draw more and more rectangles, as a number of rectangles goes towards infinity, bring the concept of limits in, we get a closer approximation to the actual area underneath the curve. So the reason this is called a left rectangular approximation method is for each of these rectangles, the height is the value of the graph at the left endpoint of the rectangle. You see the first rectangle, the height is the left, where the left meets the graph. The second rectangle, the height is at the top left corner. The third rectangle, from 4 to 5, it's just what the function value is at 4, the height. The last rectangle, we're using the left, where the left touches the rectangle as the height. This approximation is called a Riemann sum. So below is a graph of f of x equals 4x minus 1/2 x squared. Use Riemann sums to find the approximation of the area underneath the curve. So the interval is from 2 to 8, and we want to use 3 subintervals. So 2 is right here, 8 is here. If they say 3 subintervals, they just want you to break up each rectangle's width into 3 rectangles to cover this whole width. The easy way to do that is take the second number here on the interval, subtract the first number, so 8 minus 2, divide by how many subintervals you want. 8 minus 2 is 6, divide by 3, that's 2. So the rectangle's width is going by 2. The first rectangle is from 2 to 4, second rectangle is from 2 to 6. 4 to 6, and the third rectangle is from 6 to 8. Now, using the left endpoint of each rectangle, so the first rectangle 2 to 4, we want to, from the 2, go up to the graph, so that's f of 2, and that is the height for our entire rectangle. From 4 to 6, we start the 4, f of 4 is the height, and that's the height for the entire rectangle. For 6 to 8, we're taking f of 6, and that's the height of our whole rectangle here. So now to do the math here, find the area of each rectangle. The first rectangle, it's base times height or length times width. The base here is 2 multiplied by the height. This is, we can say, looks like 6, but we're just going to use, since we have the function, we can plug in 2 into the function to get our height. And that's just represented by f of 2. Because this height here is just what f of 2 is. Plus the second rectangle, which is going to be 2 times f of 4. The third rectangle is 2 times f of 6. Now if we do this all, now if you find f of 2, f of 4, and f of 6, we have 2 times, plug the 2 in, 4 times 2, which is, I'm just writing out 4 times 2, so 4 times 2, let me write that a little nicer, 4 times 2 minus 1/2 times 2 squared plus 2, 4 times 4 plus 4 times 4 minus 1/2 4 squared. Oh, that was not a 1/2 times parentheses 4 squared. Again, we're just plugging in the 4 into the function. Now we're finding f of 6, 2 times plugging in 6 in the function. Instead of 4x, it's 4 times 6 minus 1/2 parentheses 6 squared. And if you do that all onto the calculator, all you get is 40. So this next one here is the right Riemann sum. Same interval and 3 subintervals as well. So it's from 2 to 4, 4 to 6, 6 to 8 as the width of the 3 rectangles. So you can try this. So this is now the right Riemann sum instead of the left. You can try this on your own, pause it, or you can follow with me as I do this. So from 2 to 4, instead of starting at the 2 like we did with the left Riemann sum, we're starting at the right endpoint, the 4, and we go up. So f of 4 is the height of the first rectangle. Second rectangle, we're taking the right endpoint, 6, go up to the graph. That's our second. And then from 6 to 8, well, that's just a flat, that's a height of 0. And then one thing I forgot to do, you can actually shade these in. It's a rectangle, rectangle. Forgot to shade these ones here. So what we do here is do the math now. First rectangle, that's 2 times f of 4 plus 2 times f of 6 plus the last rectangle 2 times f of 8. So 2 times f of 4, same thing. We can plug this into the calculator here. F of 4, that's going to be, well, 4 times 4. Sorry, 4 times 4 minus 1/2 4 squared plus 2 times 4 times 6 minus 1/2 6 squared and plus 2 times, I'm going to just say 0 here. If you plugged in the 8 into this equation, you're going to get a 0. And you can see clearly from the graph it's just a height of 0. So I'm going to leave that. But what you end up with is approximation with the right Riemann sum of 28. So 2 more examples with these. Now we're doing the midpoint Riemann sum and then the trapezoidal sum. So midpoint is the same thing. The width of the rectangles are 2 because it's from 2 to 8. It's a distance of 6. Divide that by 3 to get the width. 2 to 4, 4 to 6, 6 to 8. So what we're doing here is we're taking the height. So the first rectangles from 2 to 4. We take the height at the midpoint. So from the 3, you go up to where the graph is. It's about right here. That's where you draw the top of your rectangle at. That's the height of your rectangle. That's the area of your first rectangle there. Now, from rectangle 4 to 6, the midpoint is right there. Looks roughly the same height. And that's a rectangle for the second one. Now from 6 to 8, you go start at the midpoint 7, you go up wherever that is on the graph, and then you draw your rectangle with that as the height. So in order to write this out mathematically, the first rectangle, it's 2 times the height, which is f of 3, plus the middle rectangle, the second rectangle, is 2 times the height, which is f of 5. The third rectangle is 2 times f of 7. So in this case, I'm going to save all the computation, all the algebra here. But again, it's the same thing as the previous 2 problems above. all you do is plug in, sorry, on the previous page, all you do is plug in the 3 into the function, the 5 into the function, 7 into the function. You should end up getting an answer of 37. I'd recommend you try this on your own on the calculator and see if you get the same result. But after everything, you should get 37. So trapezoidal sum. This is the most tedious one. So trapezoidal sum, let's just take our first rectangle, 2 to 4. We're going to do it piece by piece here. A trapezoidal sum is your left endpoint, you go up to the graph, just to where the graph is. And on the right endpoint, you go to where your graph is here. And then you connect those 2 points, so this forms a trapezoid. See how this is a trapezoid right here? And what we're doing now is finding the area of this one trapezoid. I'll do the other 2 trapezoids later on. But the formula for a trapezoid is base 1 plus base 2 over 2 times the height. So you can think about this trapezoid, it's kind of tilted a bit. So this distance here, let's look at the height. The height would just be, because this trapezoid is kind of sideways, the height is from 2 to 4. So it's 2 times base 1 is f of 2 plus base 2 is f of 4 over 2. So again, the height is 2, because that's from 2 to 4. Base 1 is f of 2, base 2 is f of 4, and you just divide that by 2. Now let's do our second trapezoid. So our second trapezoid, the left endpoints here are already given to us. The right endpoints here, you connect them, and this gives you your trapezoid here. Second trapezoid. So this trapezoid is, again, the height's 2 again, multiplied by f of 4 plus f of 6 over 2. Now our third trapezoid, well, the red endpoint's right here. So this is the trapezoid that you have. In this case, it's just a triangle. But still using the formula, it's 2 times f of 6 plus f of 8 over 2. F of 6 plus f of 8 over 2. And if you do this all on the calculator, you could try the computations by yourself, but you should get an answer of 34. Try that on your own. If you're not getting this one or the midpoint one, please let your teacher know. So, overestimates or underestimates. If you have an increasing function, a function where the slope's positive, if you draw the left Riemann sum, right, from like 1 to 2, it's this rectangle, 2 to 3, and so on, right? You can see if you're using left Riemann sums for an increasing functions, it's always underneath the curve. So this is what we call an underestimate. Because the area approximation with these rectangles, you can clearly see is less than what's actually underneath the curve. For our right Riemann sum, from 1 to 2, we have right here, from 1 to 2, and then from 2 to 3. But if you have a right Riemann sum, you can see that this is an overestimate because all the rectangles they're all partially above the curve. And if you have a decreasing function, a left Riemann sum, like from 1 to 2 would be here. A left Riemann sum for a decreasing function will be an overestimate because all the rectangles are above. And a right Riemann sum, you see from 1 to 2 it'll be an underestimate because all the rectangles you draw with the right Riemann sum will be below the curve. So the last one, trapezoidal approximation. This one may be a little hard to see, but if I just drew like one big trapezoid here, you see if the function's concave up, like a U-shaped curve, you can see the trapezoid is going to be partially above the curve, so it's an overestimate. Vice versa, if it's concave down, like if I drew a trapezoid from 1 to 5, well, it's not a good. If I drew a trapezoid from 1 to 5, if it's concave down, you're going to have an underestimate because part of the trapezoid is below the curve here. Underestimate. All right, these are some of the last examples we're working with. Using Riemann sums with a table of values. We just worked with graphs, now let's do tables. So take a moment to read the problem. Use the following Riemann sums with the given intervals to estimate the number of gallons of water pumped into the tank during the 12 minutes. So 0 minutes to 12 minutes, that's the whole thing. 4 subintervals. So you can see we have our first subinterval of width 3. Second subinterval, the width is also 3. Third subinterval, width is also 3. Fourth subinterval, width is also 3. Again, in this case, all the widths were equal. If you're given a table, right, these don't have to necessarily go up the same value by 3 every time. It could change with each one, and that's whatever the width is what you're using. So if we're doing the right Riemann sum, right, you can take our first rectangle from 0 to 3. The width is 3, and you take the right endpoint, which is the 13, so 3 times 13. Plus, the second rectangle is from 3 to 6, this one right here. The width is 3, the height is 18, so plus 3 times 18. Now you take the third rectangle. Width is 3, the height's 23, plus 3 times the right, which is 27. If you put this all in the calculator, you get 243 gallons. Again, gallons per minute times minute, you're just left with gallons because the minutes cancel out. So, is the approximation greater or less than the true value? Why? So, we have an increasing function and we're doing a right Riemann sum. So if you remember back to what we previously did on the last page, this is going to be greater than. Greater because right Riemann sum on increasing function. This question here. So left Riemann sum. Now we're doing the left. So from 0 to 3, the width is still 3, but instead of taking the right, in the previous problem we had 13, we're taking the left as the height, which is the 7. 3 times 7 plus, you take the second rectangle here, use the left height, 13. So 3 times 13, and so on, 3 times 18, plus 3 times 23. The answer is 183 gallons. And this is less than because this is a left Riemann sum on an increasing function. On an increasing function. So this next one here, midpoint Riemann sum with 2 subintervals. So notice in this case it's 2 subintervals. So it's from 0 to 6. Sorry. So we have 0 to 6. Draw this down here. 0 to 6 and 6 to 12. And this is only for this problem, the midpoint. So it's 2 rectangles now. The width is going to be 0 to 6, which is 6, Well, you multiply that by the middle. Instead of the left, which is 7, or the right, 18, it's the middle, which is 13. 6 times 13, and you plus the width of the second rectangle is also 6, but you take the middle number here, which is 23. And then if you do that all on the calculator, you're going to get 216 gallons. All right, this last problem here is the trapezoidal sum. This is back with 4 subintervals. So, take the height 0 to 3. So the first trapezoid is 3 multiplied by base 1, which is 7 plus 13. 7 plus 13 over 2. That's our first trapezoid. Second trapezoid. Height is 3 again, times, on the top of the fraction, 13 plus 18 over 2, plus 3 times 18 plus 13. Or sorry, 18 plus 23. You should start noticing the pattern now with these. Plus the height here is 3 again, times 23 plus 27. And that's all over 2. And if you put this all on a calculator, you end up getting a value of 203 gallons. Sorry, I meant 213 gallons, not 203, my bad. On the calculator, you should get 213 gallons. If you have any questions with the notes, please let your teacher know. Otherwise, go ahead and get started with the practice.